This is our calculus project, and in this we researched the effects of senioritis because it is our senior year and some of us are having a hard time in calculus. So how we did this is we took a group of 20 seniors and surveyed their GPAs over the year. So we got 9 data points over the course of the year to kind of see their effects of senioritis and which of them are decaying or increasing. And we put our calculus usage knowledge to this, and we're able to come up with senioritis being a confounding variable in the GPA drops. Breaking news! Senioritis is sweeping the nation with GPAs dropping faster than a fat kid on a water slide. We look closer at 3 specific Evergreen High School students and their journey through their academic senior year and their effects of senioritis and laziness.
Ain't nobody got time, ain't nobody got time, ain't nobody got time for that. Ain't nobody got time for that. Ain't nobody got time for that. Ain't nobody got time, ain't nobody got time, ain't nobody got time for that.
In that vein of thought, the government has the potential to enhance the productive capacity of the economy and make us much better off as a result, you know?
Oh, okay. Hey, where's Otter?
Oh my god, I need to call him. Class starts in like 5 minutes.
Hello?
Bro, class starts in like 5 minutes. Where are you?
5 minutes?
Yeah.
Ugh.
Ain't nobody got time for that.
Student A began the year with a 4.0 and ended the year with a 3.2. It is apparent that there was exponential decay of their GPA, and the equation of the line is y equals 3.82e to the negative 0.023x. We then found the derivative of this function, which is y prime equals negative 0.088e to the negative 0.023x. By plugging in months 3, 6, and 9, we were able to find the rate of change at these points. For month 3, we found that the rate of change was negative 0.082. For month 6, the rate of change was negative 0.0766. For month 9, the rate of change was negative 0.0715.
Okay, for student B, we recorded his GPA. At the beginning of the year, it was a 4.0. By the end of the year, it was a 3.8. The equation for this line was y equals 3.9863e to the negative 0.006x. We found the derivative of that line, which is negative 0.024e to the negative 0.006x. We found the rate of decay of his GPA after 3 months, 6 months, and 9 months. We did this by plugging in each number to the derivative. So after 3 months, his rate of decay was negative 0.0235. After 6 months, it was negative 0.0231. And after 9 months, it was negative 0.0227. This student was clearly not affected by senioritis as much as the majority of his classmates. This could be due to his extracurricular activities, or he was very motivated to keep his grades up. Maybe he had a scholarship he had to uphold. Either way, he wasn't affected by senioritis.
After testing student C, we found that their GPA decreased from a 4.0 in the first month to a 2.2 in the ending month. And you can see in the graph the dramatic decrease unlike the other 2 students. And then we found the derivative equation to be y equals negative 0.208 e to the negative 0.058x. After that, we found the rate of change of their GPA over the months, so we plugged in 3, 6, and 9 to find that after 3 months, their GPA changed by negative 0.1748. After 6 months, it decreased by 0.1469, and after 9 months, decreased by 0.1234. And in this, we found that student C was the most affected by senioritis and decreased the most in GPA and the rate of change. The student skipped class a lot and never attended and gave up all effort and has little hope of getting into the same college still. The end.
Alright, so for our project we also found the average values of the GPAs over the course of the 9 months, and so we used the average value theorem. And the average value theorem is when you do 1 over b minus a and then the integral, and then you multiply it by the antiderivative of the equation. And so what we did first for student A, we found from 0 to 9 months, and we started with their equation at 3.8229 e to the negative 0.023x. When we plugged that into our calculator, which I need to show those, don't I? Okay, when we plugged that into the calculator, we found our antiderivative as 31.0789. Then you multiply it by 1 over b minus a, which is 1 over 9, and we found that their average GPA over the 9 months was 3.453. Alright, for student B, we did the same process, and it's the same amount of months, so we still use 0 to 9. Their exponential decay was 3.9863 e to the negative 0.006x, so it was not as big of a drop. So our antiderivative was 34.92 when plugged into the calculator, and we once again multiplied that by 1/9, and we got their average to be 3.88. Then our final student was student C. We had the same months again, 0 to 9, and their equation started at 3.5819 e to the negative 0.056x. When we plugged it into the calculator, found the antiderivative, found it as 25.23, multiplied it by 1/9, and we got that to be 2.8 as their average GPA.
Today, we are interviewing one of the worst cases of senioritis we have found across the nation in the halls of Evergreen High School. He is similar to our student C demographic, and now over to Nikola, sitting with him right now.
Thanks, Mitch. So, Otter, I hear you have a really bad case of senioritis, which is a bad disease sweeping the nation.
I do.
I'm sorry to hear that. Well, how's your GPA been all year?
I don't want to talk about it.
Okay. What should you be doing right now?
I have a midterm tomorrow.
Oh, good. How is college looking for you? What are the perspectives for that? It's not looking good. It's not looking good, folks. Let's just use Otter as an example to know. Don't let senioritis affect you. It's a terrible disease, sweeping seniors across the nation. It's a problem that needs to be corrected. Focus and stay
In school.